These equations you're going to solve by factoring.
Negative 2 divided by 2, is that 1 or is that
Negative 1. We're going to solve by factoring, so you need to come up with the factor pairs so that when I multiply this, I get, this is the correct factoring. Oh, the way you can do that is you can take the last number, 6, this number right here, and you got to come up with the factor pairs for that. So 1 times 6, 2 times 3, and in this case, they both add up to the middle term. So x equals negative 2 and negative 3. So there's like 2 or negative 3. There are 2 possible values. Alright, so we have here the last number is 20. So you have to have factor pairs of 20. That's 1 and 20, 2 and 10, 4 and 5. These middle 4 and 5 combine to 9. So you have x minus 4, x minus 5, and the final answers are positive 4 and positive 5. So now, for this problem, you have to come up with 2 numbers that multiply to negative 12. Let's do 12. We'll look at the differences. 1 times 12. The square root of 1 is 1. 1 times 12 is 12. 2 times 6. 3 times 4. In this case, 3 and 4 have a difference of negative 1. That's going to come up to match the middle term. So it's x minus 4 times x plus 3. The two values are x could be equal to 4, but x could also be equal to negative 3. So if you talk, you'll be on the thing, but you don't have to. Well, it's already started, so that got on there. Okay, so you need to have 2 numbers that multiply to 16, right? So 16 will be 1 times 16, 2 times 8, and 4 times 4. And 4 times 4 are also what add up to positive 8. So when I factor, I've got x plus 4 times x plus 4. And the directions were now, the directions on this particular problem say solve the quadratics. So what that means is this, you rewrote it, but to solve you actually have to find the value of x. So x could be negative 4 from the first one, right? But also the second one. So this is one of those cases where there's only one solution. If you went a little step further and you actually graphed it, it would look something like this, where there's only one intersection, but that's getting ahead of ourselves. Alright, so we've got 2 numbers that multiply to 21. 1 and 21, and 3 times 7. That's the only factor pairs. Now, 1 times 21 also adds up to 22, so we can do x minus 1 times x minus 21. That's factored correctly. Now you've got 2 solutions. X could be equal to 1 or 21. So you've got, for this one, 2 numbers that multiply negative 21. 1 and 21, 3 and 7. 3 and 7 are the only ones that have a factor pair that would add up to 4 if you took the difference. So x minus 3 times x plus 7. The solutions are 7, negative 7, or positive 3.